So dear students, welcome to my YouTube channel PCM Academy and myself Hussein Munde. And we are in a lecture series on IDGM mathematical physics. And in the last class I have discussed about double integration and what is the physical meaning, geometrical significance of double integration, and how we can evaluate double integration. And we have seen that there are two methods or two ways of solving the double integration, and this is just a matter of convention. So how you can solve the integration? If the limits are given, then you are bound to solve in just one way. But if limits are not given, if there is a curve or there is a geometrical figure, okay, and you have to find the double integration and the region of double integration is given, then you can choose as you wish the limit, okay, and out of two methods you can use any one of these. But if there is a limit, then you should have follow the way the limit is given. Okay, so now let me solve some problems so that your understanding will be more clear. Okay, so let me take the first question. Okay, so here the question is that evaluate the double integration 0 to 1 and 0 to x e to the power of y by x dy dx. And from this integration you can see that here the limit is 0 to x, and when it is 0 to x, then obviously this limit is for y. Okay, it cannot be x is equal to x, but it is y is equal to x. So when the limit is given in terms of x, then you can readily say that this limit is for y. And if this is in terms of y, if 0 to y or 0 to y square, something like that, then you have easily tell that this limit is for x. So here the limit is in terms of x, so the limit is for y obviously. So we have to first integrate with respect to y of this function e to the power y by x, that I have given here. That I have separated this integration with this red box, that e to the power y by x into dy. So we have to integrate this first because here the limit is 0 to x. Okay, so how you can solve this integration? This is a very easy integration because this is this kinds of integration, e to the power x kinds of integration, e to the power x dx. I think you know this kinds of integration from your 10+2 level, that it will, what is the integration of e to the power x dx? So it will be just a e to the power x, a e to the power x, and here a is nothing but 1 by x, because here x will be treated as constant as the limit is x. So here for this integration x will be treated as constant. So here the a is 1 by x, so here a is 1 by x. So if a is 1 by x, then you can see, so what will be this, this integration is e to the power x divided by a. Okay, so e to the power mx or e to the power x is e to the power x. For derivative it will be a to the power x. Okay, so if a is equal to 1 by x, then what will be your integration? Your integration will be simply 1 by x into e to the power y by x. So, and this 1 by 1 by x actually, and this 1 by 1 by x is nothing but x. So your integration will be x e to the power 1 by x. And now you have to put the limit from 0 to x, but be careful when you are going to put the limit, because you have to put the limit instead of y, in place of y, not in place of x, because the integration is with respect to y. So you have to put the limit on y, only on y. So upper limit is x. So if you put x here, then x and x will be cancelled out, so it will be e just. So the first term will be x e. Now when if you put 0, so e to the power 0 will be 1. You cannot put 0 for this x. Okay, be careful. You have to put this 0 only instead of y. So it will be e to the power 0 and e to the power 0 will be 1. So it will be just minus x. Okay, so x e minus x. Now it is a very easy integration. It's 10+2 level integration. That is e and x. Integration of x is x square by 2 minus again x, it is x square by 2, and we have to put 0 to 1. So if you put 1 here, it will be 1 by 2, and if you put again 1 here, it will be again 1 by 2. So if you take common 1 by 2, it will be half into e minus 1. Okay, so this is how you can solve this integration. So when the limit is given, you have to follow according to the problem. Okay, so now let me give the next problem. Okay, so this is the next problem. We evaluate the integration 0 to 1 and 0 to root 1 plus x square. Okay, so again here the integration is in terms of x, the limit is in terms of x. So you have to readily say that this is with respect to y. You have to evaluate the integration first with respect to y, then with respect to x, because when you put the limit instead of x, in place of x, then what you will get? You will get the whole function as x, and you have to integrate then it with respect to x. So first you have to put this integration within this bracket. I have given here within this bracket, that is 0 to root 1 plus x square dy. You have 1 plus x square plus y square. Now it is, you have to take x as constant. So this term is now constant. 1 plus x square is now constant. So it is this kinds of integration. Integration dy divided by, you can say, a square plus y square. This kind of integration now, because 1 plus x square is now actually a square you can take, or you can take this as root 1 plus x square as a. Okay, so if you take this root 1 plus x square as a, then it will be root 1 plus x square whole square. So that will be 1 plus x square plus y square. So a will be root 1 plus x square here. Okay, now this integration, you know, dy by a square plus a square is nothing but 1 by a tan inverse y by a. 1 by a tan inverse y by a. So here tan inverse, this is y and this is a. So 1 by a means 1 by root 1 plus x square. Tan inverse y by a is root 1 plus x square. So now you have to put the limit from 0 to root 1 plus x square. Okay, so again you have to very careful about when you are going to put the limit, because limit is only substitute in place of y. So first you have to put here, instead of y you have to put here 1 plus x square. So if you put here 1 plus x square, then this will be cancelled out. So it will be tan inverse 1, and tan inverse 1 will be nothing but pi by 4. So tan inverse 1 is pi by 4, and this is as it is 1 by root x 1 plus x square. Now this pi by 4 is constant, so it can be taken outside the integration. So the final integration is dx divided by root 1 plus x square. And you know dx, you know this kinds of integration, I think you know that dx divided by root square plus x square. So now this integration is here. Okay, and this integration is nothing but log x plus root square plus x square. So this integration is now very simple. Okay, so here instead of a, this is 1, so it will be log e base x plus root x square plus 1. Okay, from 0 to 1. Now if you put 1, then it will be 1 plus root 1 plus 1, that is 1 plus root 2. And if you put 0 here, then this will be 0, this will be 0, so it will be log 1 only. So log 1 will be 0. So upper limit is first 1. So if you put 1 here, you will get 1 plus root 2, and if you get 0 here, you will get log 1, and log 1 will be 0. So the final result will be pi by 4 log 1 plus root 2. Okay. So now let's move to the next question. So here, this is the different kind of questions, something different from the other two. Here the curve is given, and you have to choose the region, you have to choose the limit yourself. Okay. So here the integration is, the question is here, find the area of the first quadrant of the ellipse. This is the equation of ellipse. This is the well-known equation of ellipse, you know. You have to find the area of the first quadrant of this ellipse, and from this find the total area enclosed by this ellipse. So if you want to find out the total area, you have to first find out the first quadrant, and there are 4 coordinates, so you can multiply with 4 and you will get the total area. So first you have to find out the area of the first quadrant. So here I have given the drawing also. So and the area, you know, is simply integration dx dy. Simply double integration dx dy is nothing but the area. This is the area under any curve. Okay. So now you have to put the limit. So here this is the equation of ellipse, you know, x square plus by y square plus y square by b square is equal to 1, and the same another axis is b and the same other axis is x. So x will vary from 0 to a for the first coordinate. You can see here x will vary from 0 to a, and y will vary from this line, and this line is nothing but y is equal to 0 line. This is y is equal to 0 line to this curve, up to this curve, and this curve is what? This curve is, you can find here the value of y from this equation. So here the first limits of x are very simple. The x1 is equal to 0 and x2 is equal to a. So the limits of x are constant. So we have to first integrate with respect to y. So we have to find out the limit of y, and limit of y1 is 0, because this line x axis, and x axis is nothing but y is equal to 0. But you have to move from here to this curve. So this is a small strip you have this small strip, and you have to cover this whole area. So if you take this strip, and this strip have to move from here 0 to a. So these strips will move from 0 to all the strips, and it will cover this whole area. But in that case, you have to choose the final limit of y2. This is, you can say, y1, and that will be y2. If you put y2 in this equation, then you have to find y2. So you can find here from this equation, that is x square by a square plus y square by b square is equal to 1, and that implies that y square by b square is equal to 1 minus x square by a square. So y2 will be b root 1 minus x square by a square, and if you now subtract this, it will be what? It will be a square minus x square by a square, and this square is under root, so it will come out, and it will be b by a root a square minus x square. So this will be the y2. Okay, so now you have to integrate this from 0 to a for the limit x 0 to a, and for y the limit is 0 to b by a root a square minus x square. Okay, so now you can easily do the integration dx dy. See, for the x the limit is 0 to a, and for y it will be 0 to b by a root a square minus x square, and we have to first integrate this dy, and this dy is y, and if you put the limit, it will be b by a, it will be b by a root a square minus x square. Now dx is there, so now this is this integration root a square minus x square into dx. It is totally converted the function of x and single integration. So this b by a is constant, so it can be taken outside the integration, and now this root a square minus x square dx, just a formula based integration, and the formula of this is a direct formula, you know, from your previous class, from your 10+2 level. There is a direct formula of root a square minus x square dx. So it will be x by 2 root a square minus x square plus a square by 2 sin inverse x by a, and you have to put the limit from 0 to a, from 0 to a. So now if we put a first, so this will vanish, this term will vanish, because a square minus a square is 0, and what will be this term? If this is sin a by a, so it will be sin 1, sin inverse 1, and sin inverse 1 is nothing but pi by 2. So this a square by 2 will be survive, and here 1, here pi by 2. So first term will be a square by 2 into pi by 2, and b by a will be there. And now minus, you have to put the lower limit. So if you put the lower limit, so obviously this term will vanish, and this term will also vanish, because here is x. So if you put x is equal to 0, then it will be 0. So this will be the result of this integration, that is b by a into pi square by 4, that is pi a b by 4, as we expected. We know the area of the ellipse, and total area will obviously 4 into pi a b by 4, that is pi a b. So area of ellipse we know pi a b, and so obviously the first quadrant, or for one quadrant it will be pi a b by 4. So this result is very important, and we know the result, but it can be verified by this double integration like this. Okay, so now let me move to the next question also. Okay, so this is the question now. So evaluate this integration xy dy dx, where r is the quadrant of the circle x square plus y square is equal to a square. So where x greater than equal to 0, y greater than equal to 0. This means again the first quadrant, x greater than equal to 0 and y greater than equal to 0. So we have to take the circle on the first quadrant, that I have taken here on the first quadrant. Okay, and this equation will suggest the limit of the integration. And if you see here, as the equation of circle is x square plus y square is equal to a, so this is the radius, this is the radius, so obviously this is a. So x will vary from, again it will very easy, that x will vary from 0 to a, and y will vary from this line, that is y is equal to 0 line, to this line. And what is this limit? This limit is from here, y is equal to root over x square minus x square. This is very easy, because you can find the limit here from directly, that y square is equal to a square minus x square, so y is equal to root x square minus x square. And as this is greater than 0, so there is no scope of putting the negative sign here. So y is equal to root x square minus x square is the final limit of y. So if you take this as y1, then you have to take this as y2, because the strip is from y2 from 0 to this curve, and now this strip have to move from this side to this side, from x is equal to 0 to x is equal to a. If you move this strip, then you will get the total area. Okay, so you have to integrate first with respect to y, and the limit of the y will be 0 to root a square minus x square. Okay, now the y dy, integration of y dy is nothing but y square by 2, so it will be from 0 to root a square minus x square, and x dx will be as it is. And now you have to put the limit here, so y square by 2, and if you put instead of y, it is a square minus x square by 2, and for 0 it will be 0. So the only survivable term will be x into a square minus x square, because from here we will get half into a square minus x square, and half is taken outside the integration, and this x will be here, so it will be x into a square minus x square dx. Now it is again totally converted into a single integration, which is just a function of x. So we have to integrate it now with respect to x. Okay, so now if you put the limit, if you first you have to do the integration. So here x and x square is constant, so x will be what? X will be x square by 2, and here x square and this x will give x cube, and the integration of x cube is x to the power 4 by 4. So it will be a square x square by 2 minus x to the power 4 by 4, and you have to put a instead of x first, upper limit. So it will be a square by 2, and a square by 2 into a square will be a to the power 4 by 2, and here we already have x to the power 4 by 4, so it will be a to the power 4 by 4, so it will be a to the power 4 by, here we will get a to the power 4 by 4 and into half, then it will be a to the power 4 by 8, and this will be the result of this integration. Okay, so this is how you can solve the problem. Okay, so now let me move to the next question. Here the question is same as before, but the region is different. Here the region was the first quadrant of the circle x square plus y square equal to a square, but here the region is different, and the region is bounded by, so please first read the problem very carefully, and evaluate integration xy dy dx in this region A, where A is the domain bounded by x-axis, ordinate x is equal to 2a, and x is equal to 2a means it's a line parallel to y-axis. This is x is equal to 2a, and the curve x square, so it will be x square is equal to 4ay, and the curve x square is equal to 4ay, you know, this is the x square is equal to 4ay curve, or you can say this is y is equal to x square by 4a curve. Okay, so these two lines, one is curve and another is straight line, will make the region A. Okay, so this is given, A is the domain bounded by x-axis, so this is x-axis, and this is x is equal to 2a line, and this is y is equal to x square by 4a, or x square is equal to 4ay curve. So these three lines, so this three curve will give you this region, and you have to integrate over this region. So what will be the limit? So the limit of x will be again very simple, it will be from x is equal to 0 to x is equal to 2a. Now what will be the limit of y? So for y, initial y1 is 0 because it is from x-axis, and up to this curve you have to move the strip from this type point to this point. Okay, so it will be y is equal to just x square by 4a, you can say. So y1 will be 0 and y2 will be x square by 4a. So you have to put the limit x 0 to x square by 4a, and the limit of x is 0 to 2a. So it will be 0 to 2a x dx into integration 0 to x square by 4a y dy. So again you have to first integrate with respect to y. So y dy is y square by 2. Now if you put this limit, it will be x to the power 4 by 32a square, because if you put y square here, it will be x to the power 4, and 4a will be 16a square divided by 2, that will be 32a square, x to the power 4 by 32a square, and this x dx was already there. So now it will be x into x to the power 4 will be x to the power 5, and this will be 1 by 32a square, and the integration of x to the power 5 dx is nothing but x to the power 6 by 6 from 0 to 2a, and this is the constant 1 by 32a square. Now if you put here 2a to the power 6, then it will be 64 a to the power 6, because 2 to the power 6 is nothing but 64, and a is here, so it will be a to the power 6 by 6, and here is 1 by 32 a square. So 6 you can say is 32, and 64 will be 2, and 2 and 6 will be 3, and this a square and a to the power 6 will be a4, a to the power 4, so it will be a to the power 4 by 3. Okay, so this is very easy, you can solve this double integration like this. Now in the next class I will discuss about how to change the variable of this integration. So you have to sometimes solve the problems in polar coordinate. You will be more comfortable in plane polar, cylindrical polar, and as well as spherical polar coordinate. So I will see in the next class change of variable, then also change of integration, order of integration, change of order of integration. Okay, so these are the some initial problems, so that you can understand the double integration very well, and you have to practice these problems so that you can be very easy. Very frequently you have to calculate this kinds of situation, these kinds of problems. Okay, so thank you.